This is going to be one of those VJ Loop tutorials. We'll be going through various concepts and you'll be learning quite a bit about attributes and geometry nodes. So with that out of the way, let's begin the tutorial. In our default scene, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and then we'll change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, after which we'll zoom in, select the group input and tap X to delete it. Now essentially I want a bunch of cubes to be present on this side as well as this side. So let's press Shift A and search for a grid, which is going to act as the base plane on which we'll instance the cubes. So let's just plug the grid into the group output and we'll set the size of the grid according to what we want. So I require it to be 20 units on the y-axis, so I'll change this to 20, and that's because I want the camera to move 20 units for the loop to occur. Apart from that, I need some more distance on the x-axis. Once we rotate it about the y-axis, it will act as our height. So let's increase the x-axis to something like 10 for now. We might change this later on. Next, I'll press Shift A and search for a transform geometry node, plug that in right off the grid, and now let's actually move this around. So the first thing that I'll do is rotate it about the y-axis by like 60 degrees so that it's a nice slope that's been created, after which we need to move it on the x-axis by a bit. So let's go to 7, which is our top view, and then just move it on the x until the right side corresponds with the y-axis. So that seems fine. Now if you want it to be very precise, of course we don't require that. You could technically use trigonometry to figure out exactly how much we'd have to move it by on the x-axis. I'll leave that trigonometric exercise to you as a homework and we'll deal with that in a future video. Next, we'll move it up on the z-axis. So we'll press 3 to go into the front view and then just move it up till it becomes flush with the y-axis. Now we need another copy of this. So let's press Shift A and search for a join geometry node so that we can have both the versions. And let's just duplicate this transform geometry node to the top and connect the grid into the transform geometry and this into the join geometry. But we need it to be rotated in the opposite direction. So let's take this y and make it -60 and then just move it on the x to a +2.6 and you should have a mirror image. Next, we can press Shift A and search for a distribute points on faces node and plug that in right after the join geometry so that you get all of these points. Next, we need to instance some cubes onto each of these points. So let's press Shift A and search for an instance on points node, and for the instance we'll actually use a cube. So let's search for a cube and we'll plug it in. Now there's a lot to be changed about this, starting off with the rotation. If the cubes are present on the left hand side, we want them to rotate by +45 degrees on the y-axis, and if they're on the right side, we need them to rotate by -45 degrees on the y-axis. And we'll talk about why we do that in a second, or we'll just show you why. If we rotate it by just 45 degrees on the y-axis, they all look like they're oriented correctly itself. You can always reduce the scale a bit and you see that they're rotated correctly. And in this case, since we moved these by 60 degrees, let's rotate this as well by 60 degrees. But as you can see, on the right hand side, they're not flush with the normal of the plane. The normal is something like this. So they're not really oriented in that direction because this is the plane. They're oriented something like this. On the other hand, if we look at the left hand side, the normal is perfectly aligned with the alignment of the cubes. So that's why we need to make sure that they're rotating by different amounts on the different sides. So let's press Shift A and search for a mix node, and we're going to change this from float to vector. Now for the factor, we're going to be using the actual position of these cubes. So let's press Shift A and search for a position, and we need to check if the x-axis is greater than or lesser than 0. So let's press Shift A and search for a separate XYZ node, plug the position into the vector, and we're just going to concentrate on the x value. If the x is greater than 0, then we need it to use whatever vector we give here, and if it's less than 0, we use the vector that's given over here. So we need to map this z value to a new range and then clamp that to get our factor as either 0 or 1. So let's press Shift A and search for a map range node, and we're going to be mapping the z-axis value from a value of whatever this negative max is, but we don't need it to be absolutely perfect, from a -100 as the minimum and from a maximum of a +100 to a min of -1 and a max of 1. Next, this result can go into another compare node and we can just check if it is less than a value of 0. So let's plug this into the first socket and check if it's less than a value of 0. The result is going to be a boolean, but if you directly plug the boolean into the factor, it converts into an integer where it's 0 if it's false and 1 if it's true. So if it's false, that means it is greater than 0, which means we're dealing with the right hand side. So we can go ahead and just rotate it on the y-axis by 60 degrees, but we need to make it radians. So we say 60 into pi, so 60 star pi by 180. Next, we can just copy this value and plug that into the B socket, but make it negative by adding a minus sign at the start. Now if we plug this result into the rotation, so we should see the change, but we're not seeing this change, so we've definitely made some error somewhere. And if we look at the position value, we wanted to check if it's greater than or less than 0 on the x-axis, but we've taken the z position. So let's plug this x position into the value, and now you should see that they are oriented correctly. In my case, they're oriented away from the normal on either side, so we need to change this one to minus 1.0472 and this one can become plus. So that way they're going to be facing the normal and this looks absolutely perfect. Next, we need to actually randomize the scale. So let's press Shift A and search for a random value, and we need this to be different on the z-axis as compared to the x and y axes. So the x and y axes have to remain the same, but the z-axis can be different. So let's press Shift A and search for a combine xyz node as well as another random value node. Let's press Shift D and plug that in here, and we'll plug this into the x and the y, and for the z we'll take this second random value node and plug it in, and now we can plug this vector into the scale of the instance on points. Now for the x and the y, we'll change the min to a value of maybe 0.5 and the max we can change it to maybe 0.6, and that might look good enough, but we need some more variation on the z-axis. So for the z, I'll change the min to 0.3, and for the max I'll change it to 2, and that just gives it some more depth. Apart from that, I think I'll change the min to 0.1 for the cubes. Now this looks fine and we are technically done with the cubes. Let's just give the cubes its material. So let's press Shift A, search for a set material node, plug that in after the instance on points, and we'll choose the default material. In the materials over here, we'll label this as large cubes and we'll leave that as is. Next, we want to add in some small cubes that will be present around this area through which our camera will move. So let's press Shift A and search for a join geometry, plug that in right here, and we'll take the original planes that we had over here and just distribute a different set of points. So let's press Shift A, search for a distribute points on faces node, and plug this right into the mesh, and now this we can plug into the group output or the join geometry. So let's just plug it into the join geometry because I don't think we need to preview it right now, but we can't actually see that. However, since I already know that they should be present over here, we don't have to do anything too much. Next, let's move these points so that they come to the center. For that, we just search for a set position node and plug that in right after the distribute points on faces, and we need to move them on the x and the z axes and not the y axis. So for that, we search for another combine xyz node and we plug this vector into the offset. Now for the z and the x values, we'll use two noise textures, or a single noise texture itself will be fine, but we have to make sure that this noise texture is centered around 0, for which we search for a vector math node and we change this from add to subtract, and we subtract a value of 0.5. Then we can plug the color into the vector, and now we have noise texture on the three axes centered around 0, and we could plug this into the x and the z. But another thing that you could actually do instead of using a combine xyz is searching for another vector math node and setting it from add to multiply. This way we actually get control over the scale as well directly without having to use another node. Let's plug this vector into the vector and we'll multiply it by 0 on the y-axis and maybe 2 on the x-axis and 2 on the z-axis, and now we'll plug this into the offset. Now we should see some motion on the points, but we can't quite see them yet, so let's go ahead and continue increasing it on the x, and now you should be able to see all the points come in. Now that looks great and it's very random. I think I want to move the points a bit higher, so for that, on the subtract of the z, I'll just start reducing that value, and that way the points move higher as well. Now that looks great, but we don't want the points to just remain as points, so we're gonna go ahead and search for an instance on points node and instance a cube. So let's press Shift A and search for a cube, or we can use the original cube that we had over here itself and plug that into the instance. For the scale, I want it to be much smaller, but I do want it to be random, so I'll search for a random value node, plug that into the scale, and I'll change the from min to 0.01 and I'll change the max to 0.05, and that way we just have these tiny cubes that are floating around. Now when my camera actually moves through this, I do not want any particle to be present in my line of the camera, so for that I'm going to use a technique that is very similar to the technique that we learned in this video over here, but it's going to be slightly different. So we'll press Shift A and search for a delete geometry nodes before we instance the cubes onto the points, and now we need to choose the selection, but what we're going to do is choose the selection based on the location of the camera. Since we know that the camera is going to move on the y-axis, we're going to ignore the y-axis and we're going to check for the distance on the x-axis and the z-axis. So let's press Shift A and search for a position node so that we get the position of every single one of the points, and for the position of the camera, we can just take the camera from our outliner and drag it into our geometry node editor, and we have the location. But for the location to be updated, we need to change this from original to relative. Next, we need to compare the z-axis and the x-axis values of the positions of the points as well as the camera. So we need to search for two separate XYZ nodes, and since we won't have space to fit it in here, we'll actually shift these nodes nodes up and play around with it up here. So let's press Shift A and search for a separate XYZ node and plug this position into the vector, and then just duplicate this and plug the location into the vector of the second separate XYZ node. Now we need to compare if the x-axis values are equal to each other. So we change this from greater than to equal, and this epsilon is essentially like the error that is allowed for a float value to be equal, because maybe we want to just round it up to the nearest 1000th digit and consider that to be equal. So that's why we have this epsilon slider. However, we can use this epsilon slider like the radius around which we don't want any points to appear, and we can now plug this result into the selection of the delete geometry. So let's take this result and plug it in, and if we were to now take our camera and press Alt G and just grab it on the z-axis and move it up, we should see points that are at the exact same x value as the camera get deleted. But that's not happening because our epsilon value is way too small. If we start increasing the epsilon value, you can start seeing that if the x-axis of the points is corresponding to the x-axis of the location of the camera, the points get deleted. So by moving the camera around, you can see how the points that are selected are deleted accordingly. So let's just move it around and you can see how the points are getting deleted nearby the camera. So that's great, but you see it becomes an entire vertical strip of points that are deleted. We can increase the epsilon even more so that you can see the strip that's being deleted. We don't want the bases or points that are higher and lower to be deleted as well. So for that, we can use some Boolean math. So let's press Shift A and search for a Boolean math, and we need to check if both the conditions are true. It's close on the x-axis as well as the z-axis. Let's take this equal to, press Shift D and plug it in here. And now let's take the z values and plug it into the A and B of this separate XYZ to the equal. Next, we plug this into the second Boolean, and now we just have a square path around the camera, which is going to be deleted, preventing any points to come in the way of the camera. We can just press Alt R and RX 90 to move it straight, and when you look in, the path for the camera is always empty, but we don't require this much of a distance, so let's just reduce the epsilon down to maybe 0.5 and 0.5. Next, we can go ahead and give these particles as well their own material. So let's press Shift A, search for a set material and plug that in after the instance on points. Now with that, the last thing that we need to add in the geometry node section are just a few circles that will act as our main focus points. So let's press Shift A, search for a curved circle, and we need to convert this curved circle into a mesh to create the torus. So let's search for a curve to mesh. We'll plug the curve into the curve, and for the profile curve we'll use another curve circle. So let's press Shift D on this and plug this into the profile curve and plug this mesh into the joint geometry. Now we can't quite see it because it's probably present down here, and that's where it is. So let's first just reduce the radius on the second curve circle down to like 0.01 so that it's a nice thin circle, and then we'll use some transform geometries to move this about. So let's press Shift A, search for a transform geometry, plug that in after the curve to mesh, rotate it about the x-axis by 90 degrees, and then move it up on the z-axis till it comes into view. Next, we need to create duplicates of this as well. So let's press Shift A, search for another transform geometry, and let's search for a join geometry. So let's press Shift A and search for the join geometry and plug that in over here. Now, essentially, we want this particular circle that's created over here to be moved in front by 10 units to act as our second circle. So on this transform geometry, we'll change the translation on the Y to 10 units, and then we can plug this geometry into the geometry socket and plug this into the join geometry, and now we have a second duplicate. So that looks good enough, and we can give this its own material as well. So press Shift A, search for a set material and plug that in over here. Now for the small cubes over here, we need to actually select the material. Let's press this plus button, click the new button and name this small cubes and select that from this set material. Then for this third set material over here, we need a new material. So let's press this plus button, call this as neon torus, and then select that from this set material. Now of course you could go crazy with this, it's up to you. The torus doesn't have to just be a single torus. If you want to create rings, you could actually take this transform geometry, press Shift D and plug that in just before the curved circle, so somewhere like that, and make sure that you reset this by just tapping the backspace button. And what I'll do is I'll just press Shift A and search for a joint geometry, plug that in over here, and take the original curved circle and plug that in into the joint geometry. Now I can scale the second one up by a little bit, and that way we get these concentric rings. You could add in maybe a third one as well by just collapsing this, pressing Shift D and connecting these up, but changing the scale for this one to something even larger or smaller. It's really up to you and what you think will fit the scene. Then let's collapse it and leave that as is. Next, let's go ahead and just place our camera to finish off the animation. But before that, let's set all of our animation defaults. So let's go to the render properties, switch on bloom and screen space reflection. For the bloom, I'll just clamp it down at 4. Then I'll go to my output properties, change the frame rate to 30 frames per second. I'll change the end frame to 150 so that it's a 5-second long animation. Output folder, I'm going to choose whatever folder I want. File format, I'm going to choose FFmpeg video. Encoding, I'm going to change from Matroska to MPEG-4, and output quality, I'll change to perceptually lossless. Then I'll just press GZ with my camera selected so that they come towards the center of the circles that I created, and then I'll press 0 to go into my camera view, and then in my camera settings, I'll change the focal length to something like 24 so that it's a wide angle camera. I can go even lower to maybe 18 if I want. Then I'll increase the viewport display and change passport out all the way to 1. Then I'll press GY-10 to bring it to the start of our scene, and I'll expand the timeline a bit, press the back arrow to go to frame 0, and then tap I location. If there's any other keyframes selected or created, we'll just tap X and delete those keyframes. Then we'll go to frame 150, press GY20 to bring it to the absolute edge of the cube, and then I'll press I location. Then I'll tap A to select both the keyframes and press T linear so that it becomes a smooth loop. However, the loop seems to just end over here. So to fix that, we have to select this, press Alt D, Y, and then just move it by 20 units and press Shift R maybe 2 more times to create 2 more instances. Now, if we switch off overlays and we run the animation, we should get a perfect loop. Now, in case your playback is too slow, just change the playback from play every frame to frame dropping, and that way you'll get a realistic idea of how fast you're moving through the scene. Now, once you're happy with all of that, you can go ahead and start the materials. So let's switch our viewport shading to rendered, and let's select the default light and tap X to delete it. Then you can go ahead and first select the geometry node object and go to the material properties and switch the geometry node editor to the shader editor. Then we'll select the neon torus first, go to the nodes. If you can't find it, press the period key on your numpad, select the principal BSDF and tap X to delete it. Now I'll press Shift A and search for an emission node and plug the emission into the surface. So the next thing that we'll deal with is actually giving in some color. So let's go ahead and give this some orange color, and let's increase the strength to like something around 100, but clearly we still don't see anything, which means we haven't assigned it correctly in our geometry node tree. So let's go back to the geometry node editor, and over here we see we have large cubes itself selected. We were supposed to have neon torus selected here, so let's choose neon torus, and now we have them lit up. So let's go back to the shader editor, and that seems all right. Next, we'll choose the large cubes and we'll make them metallic. And for the roughness, I want to use a noise texture, but this is where we're going to have to start using attributes from our geometry node editor. So we're going to deal with that, but for now, we'll just plug the color into the roughness value and we'll see what exactly is happening. If we take a look at 2 of these cubes, you'll see that the pattern is exactly the same on every single one of these cubes. They have the exact same details, and that just makes it look very repetitive, and it's not that nice. And there's nothing that we can actually do to fix this. If we do try and change it to like object, we see that we still get the same repeating pattern. So we have to figure out how to fix this. And for that, we can actually use an attribute for the position of every single one of these cubes from our geometry node editor. So let's go back to the geometry node editor, and right after we instance the cubes onto this, which we did over here, we can go ahead and actually store the position of every single one of these cubes. Let's press Shift A and search for a store named attribute, plug that in right here, and we want to store the position, and the position is a vector value. So we'll change this from float to vector, and we'll change this from point to instance because we want to store the position of every instance. Now for the name, we'll call this large cube positions, so that's LCP, and for the value we can search for a position node and just plug this into the value. Now if we go back to our shader editor, we can press Shift A and search for an attribute node, and for the attribute we have to change the name to what we just stored it as. That was LCP, large cube position, and remember it was for every instance, so we have to change this type from geometry to instancer. And now we can take this vector and plug that into the location, and there should now no longer be any type of repeating pattern in any of these cubes. So as you can clearly see, this one has like a dark patch towards the center that this one doesn't over here, and the pattern has now become different because it's based on the actual position of the cubes. So that is exactly what we wanted, and now we can go ahead and search for a color ramp node for finer control, plug that in after the noise texture, and then we can just bring the black in but change the color of the black from a value of 0 to a value of 0.2 so that it's not completely reflective. And similarly for the white, we'll just change this to a slightly darker value by changing the value down to 0.8. Next, we'll reduce the scale from 5 to maybe 3, and we'll increase the detail to 5 and the roughness to 0.8. And with that, we're pretty much done with the material for these cubes. Next, we need to deal with the material for the small cubes. So for the small cubes, I'll just make them very metallic and I'll give them a roughness of 0.2, but I want a few of these particles to light up. And now if you press Shift A and search for an object info node and take the random value and use that as a selection for the ones that light up. So I'll show you how to do that. We can search for a color ramp node and change this from linear to constant so that we can actually have only a specific number of them light up. We can plug this random into the factor and then press Shift A and search for a math node so that we can have the emission strength far greater than 1 as well. Let's plug this color into the first socket, change this from add to multiply, and then change this second value to something like 100 so that it's very bright, and plug this into the emission strength and then change the emission color to the same orangish color that we were using. Let's just bring this up and give it that orangish color. You can see that by playing around with this slider, we can get fewer of them to light up. So now you can see we just have a few of the objects either lit up like this one or not lit like this one and this one over here. So that might seem to work, but if we go to frame 150 where we're supposed to get a perfect loop, we see that it's not the same ones that are lit up. So back then we had one of these lit up. I think this one was lit up and these weren't, and this one was definitely not lit up, but now this one is lit up. If we go back to frame 0, you see this one is no longer lit up and this is the one that was lit up. So that prevents it from being a nice seamless loop, and we have to fix that somehow. In order to fix it, we cannot use this object random method, but instead we have to store a random value for each of these in the geometry node editor itself and use that. So let's go back to the geometry node editor, and where we had this entire small cubes setup, which is over here, we'll go ahead and press Shift A and search for another capture attribute node or a store named attribute. We'll plug that in over here, and we want to store this as usual for every single instance. So we'll change this from point to instance, and for the value we just want to store a random value. So let's press Shift A and search for a random value and plug this value into the value. Now we need to give this some name, so let's go with random small cube, so RSC, and let's go back to our shader editor and then search for that random value. So let's press Shift A, search for the attribute node, and again change this from geometry to instancer, and for the name RSC because random small cube, and then we can plug this factor into the factor. Now by playing around with this socket, we get which ones stay off and which ones stay on, and that is good enough. Next, I also feel like these torus objects have too low of a geometry, so let's go back to our geometry node editor and fix that by increasing the resolution on the curved circle. So right here we'll increase this resolution till they become nice and smooth. So I think a value of 100 will be enough. Now if we go to frame 150, the same ones will be lit and it's going to be a perfectly looping animation. Next, we'll switch back to our shader editor and change this from object to world, and we'll add in some volumetrics to help with the looping. So let's press Shift A and search for a volume scatter node and plug the volume into the volume. For the density, we'll reduce it down to like 0.1, and that is good enough. Next, I want there to be some volumetric lighting as well. I'll press Shift A and search for an area lamp. So I have to go to lamp area, and then I'll just press GZ and bring it up. Now I can't quite see it, so I'll go ahead and increase the power to something like 1000, and that way I should be able to see the areas getting affected by it. Let's switch on overlays, and I still can't see it, so I'll go back to frame 0, and now I can clearly see where it is. So I'll just press GZ and bring it to just above this region, and I'll give this a very slight orangish hue itself, so that seems all right. And I'm going to actually increase the size, so I'll just press S and scale it up, so that looks about right, and I'll press GY and bring it closer to my camera. Now I can reduce the power from 1000 down to like 100, and that seems good enough. Now if I zoom in and change between frame 0 and 150, I shouldn't be able to see more things appear, but I am able to see more things appear. So I'm going to increase the density from 0.1 to 0.3. Now between frame 0 and 150, there's nothing appearing, so that's all right, but you still see some difference, and that's because the light does not move along with the camera. So let's shift select or control select the camera in the outliner, and then press Control P, set parent to object, and that way the light will move along with the camera and you'll get a perfectly seamless loop for this animation. Now the last thing that I want to do is actually add in some compositing so that this color changes over time. So for that, I'll switch over from my shader editor to the compositor workspace, and I'll check use nodes. To actually see the changes occur, I'll go down to this drop down over here and choose the compositor as camera so that we get real-time changes as well. Now I'll bring this composite output and shift it to the side and press Shift A and search for a hue saturation node. Now I can plug this in between and just play around with the hue. So let's select this node, go back to frame 0 and change the hue all the way to 0, and then tap I. Then I'll go to frame 150, change the hue to 1, and then tap I. This will make a perfectly looping animation. Let's select this hue node, go down here, press A, T linear, and that way we get a nice looping animation where even the colors go through the entire spectrum. This particular technique can actually be used to change colors for any monochromatic scene that you create, and I tend to make monochromatic scenes, so it's really easy to choose the color later on as long as I make sure that all of them have the same color. I know a lot of you use many of these videos and upload them to stock footage websites, and you create variations of just the colors. So I think if you use this node, it'll also be much easier for you to change the colors and re-render them with variations quite fast. So with that, I feel like the scene is ready. There might be a few changes that I make before actually rendering it, but once you're happy with everything, you can go ahead and press render animation. I really hope you enjoyed this one and learned a little bit, or at least the fundamentals of how to use named attributes and even maybe the compositor and things like that. And if you've actually watched this far into the video, thank you so much for watching. The watch time really helps me. I started off this channel by making time lapses and I haven't done one in a while. So for the next few days, I'll actually be uploading time lapses of me creating a few different animations. Of course, if you want tutorials for those, you can let me know and I will upload tutorials for them as well. But until those come out, keep creating and stay creative.